Hello students, in this video we will be solving some trigonometric problems. Next problem is cotA plus tanB whole divided by cotB plus tanA is equal to cotA into tanB. So the LHS seems more complicated. Let's begin with LHS. We have cotA plus tanB whole divided by cotB plus tanA. So let's express cot and tan in terms of cos and sin. So this is cosA by sinA plus this is sin B by cos B. This is cos B by sin B plus this is sin A by cos A. Now let's simplify it by taking LCMs and cross multiplying. So this is the numerator, this is the denominator. In the numerator what do we have common? Sin A cos B. And when we cross multiply, what do we get? Cos A cos B plus sin A sin B. Similarly, in the denominator, what is the common? LCM, sin B, cos A. And when we cross multiply, what do we have? Cos A, cos B plus sin A, sin B. So, here, this term and this term are same. So, we can cancel it out. And we have 1 by sin A cos B whole divided by 1 by sin B cos A. So what does it become? This goes to the numerator. That is sin B cos A whole divided by cos B sin A. So we can use it. These are the two terms that we get when we separate, and we are left with tan B cotA. We have reached our RHS. This is our next problem. Cos A into cotA whole divided by 1 minus sin A is equal to cosecA. The LHS seems more complicated. So let's begin with that. Cos A cotA by 1 minus sin A. Now what we can do? We can multiply 1 minus to 1 plus sin A in both numerator and denominator. What do we have in the denominator? We have A plus B into A minus B gives us A square minus B square, which is 1 minus sin square. And in the numerator what do we have? Cos A cot A into 1 plus sin A. So we can open the brackets here. Cos A cot A into 1 plus cos A cot A into sin A. Cos A, what is cot A? Cos A by sin A. Similarly, we can write cos A into sin A. Here again we have a sin A term. What is 1 minus sin square A? 1 minus sin square is cos square A. So let's simplify. Here the sin terms gets cancelled. We are left with cos square A by sin A plus cos square A whole divided by cos square A. So let's simplify. If we separate this term and this term, what do we have? In the first term, cos square gets cancelled. We are left with 1 by sin A plus cos square A by cos square A. So this is cosec A plus 1. This is our RHS. Here we have to prove secA minus tanA by cosecA plus cotA is equal to cosecA minus cotA divided by secA plus tanA. Both LHS and RHS seem equally complicated, so you can start from either side. Let's start with RHS. We have cosecA minus cotA divided by secA plus tanA. So in the LHS, if you see, we again require the terms in terms of sec, tan, cosec and cot. So what can we do here? We can multiply the numerator and denominator with secA minus tanA, secA minus tanA. Further, multiply the numerator and the denominator with cosecA plus cotA divided by cosecA plus cotA. So what do we have? CosecA minus cotA, cosecA plus cotA, which is a plus b into a minus b, gives us a square minus b square, cos square a, cosec square a minus cot square a. In the numerator, what are we left with? secA minus tanA. Similarly, in the denominator, we have secA plus tanA and secA minus tanA. So same, we can write it as sec square a minus tan square a. And what are we left with? CosecA plus cotA. Now remember our identities. We can write cosec square minus cot square a is equal to 1, and we are left with secA minus tanA in the numerator. Similarly, sec square a minus tan square a is 1, and in the denominator we are left with cosecA plus cotA. So this is secA minus tanA divided by cosecA plus cotA. We have reached our LHS.